So this brings us to compound inequalities, which is where we're going to use what we just learned about the union and intersection of sets. So a compound inequality is essentially when you have more than one inequality, and it's going to be either joined with and or with or you might see it written like this as a three-part inequality, which is always an and question. So those are ands because it's between two values. Also, I want to point out that if it's an and question like this, that these are always going to be less than. If they're greater than, we've got an issue. Okay? So ands and ors, and they're going to be treated differently. So let's start with the ands. And again, the ands are intersection of two sets. So we're saying it has to fit both this inequality and this inequality. And that means, just like we just looked at, both inequalities would be shaded. So this is a better picture than the ones I was freehanding on the last video. But if I said x is less than 2, remember that's open circle shaded left. If I said x is greater than or equal to -3, that's closed circle shaded right. And where are they both shaded? From here to here. This side would be included. This side would not. So -3 included with a closed circle, 2 included with an open bracket. So that is an and. So here's what an and might look like. You might just get something that says and. Now the good news is we already know how to solve these things. So I'm going to subtract 3 from each side. And I'm going to add 2 to each side. So I'm done solving, and now I want to give a solution set in interval notation. So I'm saying what values are less than 4 and less than or equal to less than or equal to 4 and less than or equal to -1. So again, you can use the graph to help you. I'm going to show you what this would look like visually. X is less than or equal to 4 would look like this. X is less than or equal to -1 would look like this. Where are they both shaded? Well, it appears from this point and then everything to the left of that. So what does that look like in terms of interval notation? Interval notation would be the left-hand side, which is -infinity, all the way up to -1 and including -1. So that would be -infinity, comma, -1, -1 with a closed bracket because both of these values have -1 shaded. You might also see a compound inequality look like this. And what's very important when you solve this is you're going to just sort of pretend that -4 isn't there for a second and think, what would I do to each side? I would subtract 5 from each side. So if I would subtract 5 from each side, I'm actually -5 in all three places. So draw yourself some lines if you need to. Something has to happen at each place. -4 minus 5 is -9. 3x is left in the middle. 10 minus 5 is 5. Now I'm going to divide by 3 everywhere. -9 divided by 3 is -3. The inequality stays the same, so keep in mind it's only if I multiply or divide by a negative I have to flip it. Here, even though my solution is negative, I've divided by a +3. In the middle I have x. On the right I have 5/3, so don't turn it into a decimal, it's just fine. Interval notation for this one is super duper easy because I'm just going to use the left-hand side, comma, the right-hand side. And then I'm going to choose, because this is an open, just a less than, that's an open bracket. And because this is an or equal to, that's a closed bracket. This brings us to our or inequalities. And or, just as before, is the union of two sets, which means either inequality would be shaded. So again, same one that we looked at before with x is less than 2 or greater than or equal to -3. Anywhere from left to right would be shaded. So anything down here, I would have a dot above it. Anything over here, in this case I would have 2 dots above it, but it doesn't matter. Anything here, so we can see there's no gaps in this graph, so it's just all real numbers or -infinity to +infinity. So when I solve it, again, it's an OR question, so it's just going to be two separate ones that I'm going to solve separately. So I'm going to add 10 to each side. I'm going to divide by 6 on each side. Here I'm going to subtract 1 from each side, divide by 2 on each side. And again, they don't need a graph, they just need it in interval notation, but if the graph helps you to visualize what's going on, this one would be less than 3, or this one would be greater than 4. So this one's a little bit trickier in terms of how to write it in interval notation. If I were to write where one or the other is shaded, notice I've got this blank spot in the middle where nothing is shaded. So this first one would be shaded from negative infinity up to 3, but not including 3. Then we've got this space in the middle where nothing is happening. And then to the right, we have 4 is the left-hand side, not included, up to positive infinity. So essentially, both this and this are where one or the other is shaded. And just like we would normally, and is union. So my solution is from negative infinity to 3 and from 4 to infinity. So we had two solution sets that were sort of separated, so I have to use union to imply that it's this one and this one. So hey, give it a shot. Here are two. One is an and, one is an or. Again, the and looks a little bit different. Notice those are greater than signs. That makes me uncomfortable, but you're going to end up multiplying by a negative, so those are going to flip around to be less than or equal to signs, which makes me happy and brings joy to my heart. So press pause, try both questions, then press play to see how you did. So for the first one, again, I would solve by first multiplying by negative 3, and because it's an inequality that looks like this, I actually have to do it 3 times. So negative 3 times 2 is negative 6. This negative 3 cancels out my fraction. Negative 1 times negative 3 is 3. And because I've multiplied by a negative, my inequalities flip around, and that makes me much happier because now everything is as it should be. Now I have to add 2 to get p by itself, but that means I have to add 2 in all 3 locations. That gives me, negative 4 is less than or equal to p is less than or equal to 5. Again, this one's very easy to write in interval notation. I'm going to use my 2 values. They both have or equal to, so they're going to both be closed brackets. For the other one, I'm just going to solve each one. I'm going to add 5 to each side. Divide by negative 3. Notice I've divided by a negative 3, so I have to flip that inequality. Other one, subtract 4 from each side. Negative 1 is less than or equal to 2. Sorry, negative 1y. And then again, I have to divide by a negative, so that gives me y is greater than or equal to negative 2. So that's my or. Again, make your graph if you need to. Negative 3, negative 2. This one would be open circle, shaded left. This one would be closed circle, shaded right. It's an or, so my solution would be from negative infinity to negative 3, or union, because it's both of these, from 2, which is included, all the way up to positive infinity. So that is my final solution in interval notation.